The ability to analyze and monitor the physiology of cardiomyocytes and neurons has profound implications in biomedical research, particularly in drug development. Many candidate compounds fail in clinical studies due to unforeseen cardiac and neuronal toxicity. Quickly determining which compounds may cause cytotoxicity early can save millions of dollars in critical drug development savings. The objective of the SEPA initiative is to engineer an assay for assessment of the pro-arrhythmic potential of new drugs that has improved specificity compared with other assays. To adopt this paradigm, Molecular Devices developed a complete, high-throughput workflow for assessing cellular response to a set of known SEPA inducers of cardiac arrhythmia. The Molecular Devices FLIPR Penta, with the Peak Pro 2 software, tailored especially for kinetic screening for toxicology and lead compound identification, is a customizable, all-in-one, high-throughput cellular screening system. A newly enhanced HS-EMCCD camera option allows for up to 100 measurements per second and provides detailed information about cardiomyocyte and/or neuronal oscillation. Up to 7 LED sets and multiple filter options, including fluorescence or luminescence detection, to accommodate various assay types, including calcium flux, potassium, and membrane potential. User-interchangeable pipette modules that can accommodate manual and automated assays in 96, 384, or 1536 well throughputs. The newly released updated ScreenWorks Peak Pro 2 software calculates calcium oscillation peak data and can quickly flag abnormalities including defibrillation, depolarization, and irregular beating. After treating cardiomyocytes with FLIPR calcium assay reagents, analysis of cardiomyocyte function using FLIPR Penta is a straightforward workflow that can be customized according to your experimental specifications. To complement screening on cardiomyocyte function, the ImageXpress Micro confocal system can provide high content and high quality imaging data on cellular contractions and overall cell viability. With up to 8 laser channels and a deep tissue penetrating confocal module, the ImageXpress is capable of multiple imaging feats, from 3-day assay development to screening. Multiple studies have validated the application of FLIPR technology and ImageXpress imaging in toxicity studies of iPSC-derived cardiomyocytes. Human cardiomyocytes derived from induced pluripotent stem cells, or iPSCs, are becoming useful tools in drug development and toxicity testing. Self-renewing iPSCs provide an expandable and endless supply of sample cells from multiple individuals, which can be ideal for large-scale and longitudinal studies. These derived cardiomyocytes form a synchronously beating monolayer that replicates the intracellular calcium flux of normal heart tissue. The calcium flux assay is a long-established method of determining cellular activity, often used to observe not only cardiomyocyte beat patterns, but also neurotransmitter release, ion channel activity, and more. Human iPSC-derived cardiomyocytes were exposed to 28 SEPA compounds in 96 well and 384 well formats, and then treated with the early tox calcium dye. Using the FLIPR Penta system, calcium oscillations were recorded at speeds of 30 to 50 frames per second. This provides high-resolution information, including oscillation frequency, amplitude, peak width, peak raise, and decay times, and irregularity. After the system records oscillations, the analysis by the Peak Pro 2 software is performed, characterizing cardiotoxicity patterns for each of the 28 compounds. Next, the ImageXpress Micro confocal system is used to carry out a high-content analysis of cell morphology and viability. Live cells were stained using dyes for cellular nuclei, viability, and mitochondrial membrane potential to score both acute and chronic effects of cardiotoxicity. The end result is a comprehensive evaluation of dose-dependent cellular responses and predictive EC50 values for a large set of pharmacological compounds. Rapidly assessing the cardiotoxic potential of new compounds is crucial in shortening the drug discovery pipeline. By using Molecular Devices' high-powered reproducible screening tools, you can easily obtain robust multi-parameter cytotoxicity data.